All right, welcome back. Another stat video. Remember, as we go through getting started here, not tons of numbers today, not hardly any numbers at all, just a lot of words and some terms, but some really background stuff that you really need to know before we get too very involved in the statistics. So, statistical and critical thinking. If I could read the title, that would be great. Um, First of all, data. This first part of stats that we're going to talk about what the data is. Number one, how to prepare it, where it comes from, what the source is, and also how the sample was received or how it was gotten. Context first. A couple questions we always want to ask ourselves is what does the data mean? What are the numbers about? What is the goal of the study that somebody's doing? Number two, the source, where did it come from? Was it a special interest group or somebody that has a special interest? Is there a pressure to get results that are favorable to some source? That's very important. And we'll talk about that more tomorrow in class. And the sampling method. Were the data collected in a way that is unbiased? This can be a huge word right there. And collected in a way that cause bias. Bias just means your results aren't very good because they're biased towards one direction or another. We always want to make an unbiased sampling method if we can, and that's usually, this word right here is going to be huge. It's usually due to a random sample. We want all our samples to be random as possible. Here's a poll that was done. You can see the question at the top of the screen. Have you ever been hit by a computer virus? And here's the responses right here. That was conducted as an AOL poll online, giving people the opportunity. They could just choose to participate or not, we'll talk about that in a minute. That's not a great way to do it. And also look at their chart. The chart makes it look like yes is like 3 times as big as the no. The chart, because it starts here, starts at 40,000, doesn't start at 0, the chart's kind of confusing as well, because if you look at the numbers, it's less than, it's not even twice as many people said yes, but the chart makes it look like, wow, there's almost 3 times as many people said yes. So the chart is, kind of confusing. Plus, it doesn't really truly reflect what the numbers say, but AOL is definitely using it to prove a point that they're probably trying to sell some sort of, virus protection software or something like that. So they're really trying to make it look good. And again, they took the poll on a voluntary basis. 2 huge sentences right here. We're about to get those down. Sample data must be collected in an appropriate way, such as through a process of random selection. Those words right there are going to be huge as this whole entire year. Random selection, how you get your data through a random process. If they're not collected in that way, appropriate way, meaning random way, they may be so useless that no matter what we do to them with our stats, we're going to do a bunch of stuff with these numbers with stats and statistics, you can't even salvage them because they were collected in a bad way. So it's very important how the data is collected. And almost everything we do, the first question we're going to ask is, how did they get the data? Where did it come from? Here's one that's actually pretty good. Have you ever heard the question about, oh, I can't do this, my brain's not big enough to do this math, or my brain's too small, whatever, or you're just smart because your brain's big? Well, they've actually done studies on IQ scores and brain size, and this is just a few people right here, but the source is really good. It comes from the Journal of the American Medical Association, the AMA, and they really have no reason for one to look better than the other, a big brain being smart, or vice versa. That's what they did, and I thought it was pretty funny up here. Really, this is the 88 is one of the smaller IQs, but also had one of the bigger brain sizes. So there you go with that. It doesn't always work that way. Some random data in there, you can kind of look at that, but I thought that was pretty neat. Sampling method, everybody in our sample was between 24 and 43. So pretty good little age range right there, but no real old people like me, no babies or no toddlers or anything whose IQ wouldn't be very high. Everybody they sampled had at least a high school education. Sorry about that, somebody walked in the room. At least a high school education. And the last thing, also very important in this case, is none of their people had any kind of neurological or psychiatric disease. So nothing known wrong with their brain. So good study right there, and interesting. And the last thing today, a voluntary response sample. We'll spend some time tomorrow talking about this. Is just a sample to where respondents themselves decide. They get to decide whether they're included or not. And one thing to look at about these, well, let's do this. Here's three types of them that you see the most. One is an internet poll. You may be on the internet somewhere, and somebody said, please participate in our poll or survey, and you can decide whether you want to respond or not. You don't have to. Sometimes you get something that's mailed to you, as you grow up especially, you get stuff mailed to you. I get something occasionally asking what shows on TV I watch, and I get to decide whether to reply or not, or whether to send it in. Telephone call-ins. A lot of times your newspaper, radio, you see something on TV that says, call in this number and you can tell us what you think. Those are all voluntary response, meaning your sample you're getting is not random, it's just people who are responding. And to be honest, most people who respond to those things are people with very high opinions, strong opinions, I should say, either strongly for or strongly against. You don't get a lot of people in the middle, or some people just won't call those things. So you don't really get a good random sample when people get to decide whether they participate or not. So the bottom right there, from a stat standpoint, this kind of sample is not very useful when you're trying to make generalizations about the whole population. So you got to be careful what kind of sample we want as random as possible. So to wrap up, three things. When you're doing data or collecting data or looking at data, three things. It's all about the source, where did it come from, the context as far as why we're doing this, or is there any kind of bias towards one outcome or another, and how did you get it? What was the sampling method you used? Was it extremely random? And we'll work on this some tomorrow. Hope this helped a little bit. Look forward to seeing you.